All right, guys, let's talk more on this. The properties of the parallel lines and the angles that are formed, okay? We already saw in section 3.1 these three items. We classified the angles, of course. We quizzed you on those. And we, we wanted to formally state these ideas. We've looked at them, talked about the corresponding angles. This is a postulate, the postulate 3.1. Postulate is accepted as true without proof, okay? And I want you to look closely at how the postulates are worded because they are written as conditional statements, if-then statements. And so we're going to, in the next section, look at their converses and see that the converses are also true. So the postulate 3.1, which we've looked at, if the transversal intersects two parallel lines and corresponding angles are congruent, okay? If transversal intersects two parallel lines, then the alternate interior angles are congruent. And postulate 3.2, if the transversal intersects two parallel lines, then the same interior angles are supplementary. So we're going to look at some proofs that follow from this, but right now we just want to look at the converse of these, which is basically what's going to be illustrated here in the next section, 3.2. Okay, so 3.2, we've got the converse of the corresponding angles postulate. It says if two lines in a transversal form corresponding angles that are congruent, then the lines are parallel. So again, we've taken the converse. We moved from given the parallels to proving the parallels, essentially. Uh, and the same thing is true here. Theorem 3.3 says the converse of the alternate interior angles. So again, if two lines and a transversal form alternate interior angles that are congruent, then the two lines are parallel. Okay, and Theorem 3.4 stating the converse of the same side interior angles, so that if two lines in a transversal form same side interior angles that are supplementary, then the lines are parallel. So I'm going to illustrate these here with this sketchpad model that I did. Okay, so this is demonstrating postulate 3.2. Okay, stating that if corresponding angles are congruent, then the lines are parallel. So we start off with what we have here, which seems to show no parallels, but okay. The angles here, as marked FHG and HGB, as you can see, are clearly not equal, and the lines are clearly not parallel. However, if I were to alter these so that I could make those two angles equal, which we're right about there, okay, now that the angles are equal, these two lines, CD and AB, are going to be parallel. So this is the converse. This is the converse of the corresponding angle theorem, saying that if the angles are congruent, then the lines are parallel. Again, we don't start out with parallel lines, nor do we start out with congruent angles as labeled here, okay? But when we move the one line or any other line in an attempt to make those angles equal, then what we're going to see is those lines are going to be parallel. Okay? Now, Theorem 3.3, the flip of the alternate interior angle theorem, stating that if your alternate interior angles are congruent, then your lines are going to be parallel. And again, it's going to be illustrated here. Of course, the angles are not congruent, nor are the lines parallel. We have the angles, the alternate interior angles, CHG as marked here, and the alternate interior angle HGB as marked here. And obviously we see that they're not equal, but once we swing it around so that the angles end up being equal, these two lines are in fact going to be parallel, as is the case here. Again, we can move either one of these, moving this in an attempt to make the angle at H equal. We will see these lines moving towards parallel, and there they are. Okay, and then lastly, okay, the converse of the same side interior angle theorem. Same side interior angle theorem said that if the two lines were parallel, then the same side interior angles were supplementary. Well, again, the converse is to state that if the same side interior angles are supplementary, then the lines are going to be parallel. And of course, we're starting off with the appearance here of no true parallels and no statement saying that the angle CHG and angle AGH are equal to 180. In fact, in this position, we see they're equal to 186. Okay, so and again, the more these angles move away from being supplementary, the less likely the lines are being parallel. But if we move these angles to a position where their sum is 180, then we are going to have, in fact, parallels, as we can see here. And either way we move them, okay? I want to move it like this here, that's fine, really doesn't matter. I want to arrange for these angles to be equal, if I can, for these angles to be supplementary. And once those angles are supplementary, then in fact, okay, we do see that the lines are parallel. So, okay, that's a little introduction there for those theorems, as we saw in the theorems that we saw right here in section 3.2, which are the converse theorems of the theorems that were presented in 3.1. Okay, and a follow-up video will talk about some things regarding proofs. Okay, so that'll do it for now.